So by now, hopefully, you are a expert on functional decomposition, or well, at least you got started. But as you get started, as you get going, might get to reach the point like, well, where am I done? How do I know I have enough? When fundamentally is enough enough as you're going through your solution? Decomposition has its limits. I mean, we do want to better understand this problem. We do want to understand, how we're going to approach this problem, but we're not trying to get down to every line of source code being covered. It's a bit of a rookie mistake. The first job I had, one of the first things I had to do was understand this big block of very difficult code that literally nobody else in the company was an expert on. People who had written it had left a long time ago. Nobody bothered to keep up with it. And so the first thing I started doing was flow charting out line by line, figure out what was happening. And it was valuable for me to understand it because it gave me a structure to the code. But when it came down to it, by the time I finished doing the task, I realized like, wow, this took me a lot of time to just basically read the code. And so we aren't looking for design to get to that level in most cases. Sometimes people want it there. It's very atypical. So we want to get to the point where we understand the solution enough, and then we can describe where it goes from there. And so there's one more level of analysis breakdown that we want to consider when we get to that point. So when we get to the underlying functionality, we understand it, we can stop breaking it down, and we can say, hey, this bubble means this thing. There's some details we want to capture about what we expect that bubble to do, but we're not going to break it down into further jobs. And so that formal version of this is called a process specification, or sometimes referred to as a P-spec. It's going to capture that. It's kind of like okay, I have a procedure or function I'm going to write. This is the rules for what goes in the data for that procedure or function. And so the P-spec might be something that basically just reiterates the inputs and outputs. So, we have a P-spec such as bag groceries. So the inputs is groceries, the outputs unprepared food. And we're just going to describe what that functionality is going to do for us. It's kind of like what you would see, if you're talking about Java, like JavaDoc sort of stuff. This method takes in this inputs and returns these outputs. This is the type, this is what they do, and this is generally what this method does. And so it's going to, hey, this function is going to put groceries in a bag and get it ready to go for food travel. Now, how this happens, in this case, it's still kind of high level. Maybe we have a robot that does that. Maybe that's exactly why it's high level. Maybe we bought a food packing robot, and all we have to do is tell it what food it's going to, put the food on a container and some bags available and say bag this stuff, and the robot automatically does it. So we can just call an existing procedure or function to make that happen. We customize it a little bit, which is why we have the P-spec, but then it's good enough to go. So your design, I'm not asking you to do P-specs, just to be fair. I just want to show you about this. This is continuing on your understanding of structured design if you ever see it in a formal world. But this is where you typically terminate your process breakdown. But doesn't mean you're done. You might think you're done, but how do you know you're done? Because remember, we had that problem before of did all the inputs and the outputs match? And so there's an additional process called balancing, where we want to make sure that every input leads to or yields in an output or is used somewhere in that functionality, and every output is only generated based off of inputs. So every bubble we want to accommodate where the inputs and where the outputs, and then the further sub functions we want to assure that they're only receiving those inputs and outputs. We generally like to think in something called a pure function. A pure function is like I send you into the gym, and you come out of the gym a stronger, slimmer, more healthy you. And the only impact of there was being in the gym. We don't want gyms that have Starbucks and Krispy Kremes inside of it that's going to have some sort of side effect towards the next result that we're going to do that. So that's an analogy. It's not totally fair. But in software, what we want to think of is your outputs are only a reflection of the inputs. I don't have secret database lookups or extra variables that I can access somewhere else that are internally. That's very contrary to object-oriented programming, which is full of side effects. It thrives on side effects. But in structured design, you want to minimize those. You want to basically say, hey, I like pure functions. And so the outputs are based off of the inputs that are going on inside there. And by verifying that, I can know that my design doesn't have gaps inside of it. I know where the data is coming from. And that's definitely a fault if you've done detailed object-oriented design. Sometimes you forget where this data comes from. It's like, oh, I'm an object. It's there somewhere. And then you get down to the point of, wait, where does it come from? Now, there's secret ways to get that in object orientation. It's not what we're talking about here. But let's jump back to balancing. So as an example, we have the go shopping function. And from the go shopping, we have the shopping list coming in and the unprepared food coming out. Now, we saw this. We remember this from the one before. We saw a problem with this and when we were talking about it before. Because the shopping list comes in, the unprepared food goes out, the balancing is good. But when we looked at the solution or before, the select groceries, we have shopping lists coming in, but we have groceries and money that goes over to paying the cashier. Well, where's this money come from? It doesn't come from the shopping list. It doesn't come from the stuff that's coming into this, so where does that money come from? And this is where this activity of balancing might yield you some better understanding of all the values that are inside of there. Are they a function of that? So the shopping list comes in and we're selecting groceries based on the shopping list. Yeah, we can see that. That's good. And the output here is the groceries. Yeah, the groceries is we get them off the shopping list. We turn that into that. But then that money, that's where it comes from. So then coming in here, we probably added the money when we did balancing beforehand. So we have groceries that come to the cashier and we bag them up to go here, but we have to pay for them. So that's where this magic formula comes in. You can do some basic balancing. You can take a look for your design of what some basic balancing is. It's not a big formal process. It's not something you have to keep notes on or keep track of in that much. But if you do choose a DFD, at least go back and make sure your inputs and your outputs align. That's the key part to structured design and making sure the design makes sense. This is part of the analysis that really starts to align to the object-oriented world. You got to remember that the object-oriented world is functions plus data. Well, it's not to say that data is unregarded in structured design. Just data is passed through the system. It doesn't have a home. In the object-oriented world, you do the same sort of balancing. It says, hey, I need to know about money. Where do I go? Well, I go to the wallet object to ask for money. So you have this object that, again, it really makes sense. In Android and Apple, you do have a virtual wallet that's out there. So it makes perfect sense to have that in the world. The same sort of thing's happening here, except for instead of a wallet, I go ask for money. I'm expecting somebody to hand me the money when I go to the store. Instead of me being smart and going out and getting my own stuff, I'm expecting it to be given to me to do my job. So it's not to say one's better than the other, though. Object orientation certainly has a lot of advantages. It certainly is easier to contemplate some of this stuff in OO. But in structured design, we can do very much the same types of things by doing tasks such as balancing. So good luck, go balance your charts, and then we'll continue on to some advanced topics next.